computer guy, and I've been around the small computer business since 1978 or so, when Apple was hooked up to your TV set, and I saw IBM introduce the first personal computer in 1983. I have a computer school and a store in East Hampton, Connecticut, where I teach computer technician certification classes, and I've gotten my hands dirty on, well over 10,000 PCs, Macs, and laptops. If you're ever in East Hampton, Connecticut, please stop by and say hello. We'd love to meet you and share stories about the industry. If not, our webpage is at ontrackcomputer.com. This class is about Ethernet standard using Cat5 cable and RJ45 plugs and jacks. It's a beginner-level course on the basics of wiring and some of the rules and specific language of the business that will make you look smarter and help you to do things right when you're wiring. My friend Tim Hatcher owns a wonderful business just outside of Hartford, Connecticut called Cables and Connectors that carries just about every wire and connector that you could need. It's a technician's playground, and they seemingly have everything that you could need. And even if they don't carry it, they'll make it for you. So please stop in to see them if you're in the area, or visit cablesandconnectors.com and tell them I sent you. Anyway, Tim sees hundreds of wiring guys all day long, and he's a wealth of practical and problem-solving information. He always reminds me and my students when I have classes with him, remember that every time you do some computer wiring, you leave your business card. So, take-home message, do it right, and do it with quality materials. And as always, do it once. There have been many ways that people have wired computer networks over the years using coax cable, which is similar in looking to what your cable TV is, but using a different standard, and different types of paired wires that they use. But I'm going to focus on two popular standards of Ethernet that are used at speeds of 100 megabits per second and 1,000 megabits per second. And that 1,000 megabits per second is also called gigabit. And we're going to talk about only using twisted pair wire, which is called Cat5, Cat5e, and Cat6. Now there are other types, we're just going to focus on this. We'll talk about the differences in these cables, how they're wired, what their limitations in speed and distance are, and the different flavors of cable that are available for special needs. So let's begin. The standards for this Ethernet over a twisted pair cable was established by an organization called the IEEE, that's IEEE, and that stands for the Institute of Electrical and Electronics Engineers, lots of E's. They set the worldwide standards in technology, and they all got together in 1980 actually to get all the manufacturers on the same page with regard to network connectivity, and came out with the 802 standards. These include the specifications for Ethernet, as well as the wireless standards that we commonly use in home and business Wi-Fi today. Each standard is numbered with a subsection. Ethernet, for example, is 802.3. And I remember that because the number 3 looks like a backward E. So you can remember that 802.3 is for Ethernet. FYI, wireless is 802.11. And I happen to remember that and teach that to my students because the 11 looks like 2 antenna, which reminds me of Wi-Fi. Anyway, no need to make this stuff any harder than it already is, right? So you may ask, why is it called 802? Well, easy answer. They met in February of 1980, which is 80 second month, 802. So now you'll never forget the year or month of the 802 standard. A short pause here about the word Ethernet. The story that I heard goes that Xerox in the 1970s was concerned about news articles in the media that predicted that technology would soon create a paperless society. Boy, were they wrong. Xerox was quite comfortable with the idea of plenty of paper, since their plain paper copiers had helped to create a worldwide need for copies without using what was previously used, which are mimeographs and carbon paper. So Xerox, based on the east coast of the U.S., took some of their best research minds and they moved them as far as humanly possible away from the paper copier culture at their home office to a new facility north of San Francisco, California, in Palo Alto. This became known as PARC, P-A-R-C, the Palo Alto Research Center. Their mission was to create computer tools with the newly developed mini-computers to interconnect hundreds of laser printers and computers, and to maybe hedge their bet a little bit should the news reports come true that we were going into a paperless society. The PARC guys were massively successful, and they developed the Ethernet standard as well as such common devices as the mouse. As fate would have it, though, when they reported back to their home office at Xerox on their accomplishments, management thought that they were nuts to envision a business full of individual computers and printers. So Robert Metcalfe left Xerox in 1979, and he took his patent for Ethernet to try to convince some of the rising stars like Intel and Digital Equipment to embrace his standard. The rest, as they say, is history. By the way, all signs point to the fact that this is correctly pronounced Ethernet. I've been in this industry a long time, but every so often an Ethernet person emerges. So we have a standard. There was already a cable standard in the telephone industry known as Category 3, which defined an unshielded wire with 4 pair of 24-gauge solid wire. And each pair contained a green, blue, orange, and brown pair. That's green, blue, orange, and brown. Those are the 4 colors. In each pair, one wire is striped with a white stripe, and the other is solid. So the orange pair has a white-orange wire and a solid orange wire. By convention, we say it that way. We say the word white first, so we call it white-orange or white-green and not green-white. This cable was rated to carry the first Ethernet standard speed, which was 10 megabits per second. A quick detour, and one of my students just asked me this in class. Why would we speak of megabits per second when everything else in the computer world seems to be measured in megabytes? You'll remember that a bit is an abbreviation for a binary digit. We take the BI from binary and the IT from digit and mash them together into the word bit. And a bit is just a 1 or a 0. It's kind of the least common denominator or the basic currency of data in the digital binary world. A more useful unit for just about everyone is a group of 8 bits, which some wise-ass decided to call a byte. The various combinations of 1s and 0s in 8 bits, or a byte, can code for a total of 256 different numbers, and this is way more useful than just a 1 or a 0. For example, all of the keys on the keyboard that I'm using have a unique number assigned to them, from 0 to 255. An A, a capital L, a semicolon, the number 8, any key, each have a unique standardized number associated with them, known as the ASCII standard. That's ASCII. So I think of a byte visually as a Scrabble piece, 1 letter or character per tile, 1 letter or character per byte. When we speak of a byte by convention, we use a capital B. So GB, gigabytes, is how we express perhaps our memory or hard drive size with a capital B. With bits, though, we use a lowercase small b. So why megabits when we're talking about network speeds when everything else in the computer world is measured in megabytes? Well, it's simple, really. When you count bits instead of bytes, it's kind of like the difference between counting passengers at a toll booth versus vehicles. Obviously, if there were more than one passenger in a vehicle, we would be counting more passengers crossing through the gate than we would be counting actual cars holding them. For this reason, counting bits ends up being a bigger number. It's actually 8 times the number of bytes. So the telephone modem people years ago used to use kilo and mega. Kilo means 1,000, mega means around 1,000,000 bits per second to make their slow equipment sound peppier than it really was. The idea stuck, so now we have speeds measured in megabits, and it just is a bigger number than if we measured it in megabytes. So that 100 megabits per second Ethernet connection is really only about 12 megabytes per second, which is 100 divided by 8. But no one uses those units. So back to the point. We have 3 main speeds of common Ethernet, 10 megabits per second, 100 megabits per second, and 1,000 megabits per second. And then 1,000 megabits per second is also called gigabit. As we mentioned, the 10 speed works fine on the old phone wire called Category 3, and we lovingly shorten that to call it Cat3. But the need for speed marches on, and sadly, Cat3 cable didn't quite cut it and didn't reliably carry data at the newer 100 megabit speed that everyone was proposing. It was subject to interference from radio waves and electromagnetic interference, and those are known as RF, for radio frequency interference, and EMI, for electromagnetic interference. So since the 4 pair were also twisted exactly the same way, every so often they touched at regular intervals when the twists met, if you will. And this is all happening within the wire. And it caused a type of interference called crosstalk, where the information on one wire bled over to the adjacent wire. So great minds worked on the problem, and with the knowledge that a straight wire acts like a perfect antenna and it will pick up all the radio frequency interference in the room. The opposite was that a twisted pair of wire would be the opposite and not act like an antenna at all. You know that straight wire is a perfect antenna if you just think of all those metal tube-like antennas sticking out from old cars that were used to improve radio reception. Twisting a wire makes it resistant to picking up radio waves. My friend Tim, who I mentioned of cables and connectors, has a great description. He says that it's like tying a t-shirt up in tight knots and then dipping it into dye when we tie-dye it. The dye, like the radio interference, can't get into the knotted places. Same idea in a twisted cable. So the solution, to carry faster data, they twisted each pair, but they twisted each pair a different amount. Now the twists were tighter, and the pairs never met in regular intervals in regular places like in the Cat3 cable. So the problem was solved. This new cable, called Category 5, or Cat5, could handle Ethernet speeds of 100 megabits per second. But, as usually happens in the computer business, someone decides to take it further, and people developed a cable with even tighter twists, hoping to coax speeds of 1,000 megabits out of it. But alas, it didn't quite work. They did get the speeds up to about 350 megabits per second, though, and with this extra twisted cable called Cat5e, they found that it will run at 1,000 megabits per second for short distances under ideal conditions, but this is not something that we can guarantee or certify for this type of cable. So Cat5e actually is rated at 350 megabits per second, which is certainly faster than 100, but it's not one of the standard speeds that we use at Ethernet, in Ethernet. As the need for speed increased to 1,000 megabits per second, or gigabit, remember that giga is about 1,000 megas, so that giga is about 1 billion, and 1,000 megabits is about 1 billion. A new tactic was now required in the cable. So here's what they did to get up to those speeds of gigabit. Have you ever seen one of those plastic coffee stirrers when you get coffee and donuts? If you look at it from the end, that's actually looking down the stirrer, it's in the shape of an X with 4 channels in it. And to get gigabit speeds in Category 6 cable, they developed a 4-pair cable that has something like this long coffee stirrer sitting in the center of the cable, which physically separates each pair from one another. The central plastic core winds its way through the cable, and it kind of corkscrews or spirals the pair while it separates them. The combination of the physical insulation between pairs from this plastic piece, as well as the intense twisting, keeps the data moving along, and this is called Cat6 cable. So Cat6 cable not only has those tight twists that are different for each color pair, it also has a plastic insert in the center to physically separate the cables so that the pair so that they can't touch each other. Here's a good place for a review. You've done great. Let's take a look back. These cables are known as part of the standard known as Ethernet, which was originally defined by the IEEE 802.3 standard in 1980. Each cable has 4 twisted pair of wires. Cat3 supports 10 megabits per second. Cat5 and Cat5e support 100 megabits per second. And Cat6 supports 1,000 megabits per second, also known as gigabit. Now, let's go on to some specific materials and the rules of the road when it comes to Cat cable and Ethernet. First, there are a few specialized type of Cat cables that you want to know about. Regular Cat cable is called UTP, unshielded twisted pair. As we mentioned, it is just 4 twisted pairs of 24-gauge solid insulated wires, and the whole thing is covered in a plastic PVC outer covering. PVC stands for polyvinyl chloride, and it's just the name of the material, the type of plastic that's used in the wire covering. PVC is pretty cheap, and as of the time of this program, 1,000 feet of Cat5e cable is probably about 150 US bucks. It's the plain, vanilla, kind of everyday, commodity, kind of general purpose wiring that's often used in home and business networks. But sometimes we need to run cable in environments that are electrically noisy or filled with magnetic or radio frequency interference. You'll remember that magnetic interference is called EMI, electromagnetic interference, and radio frequency interference is called RF. You might find this where there are motors, which throw off a lot of magnetic interference, like in a machine shop, or near those humming ballasts and fluorescent lights that throw off interference also. In these instances, when you need to pull out the bigger guns, insulation-wise, you can use shielded twisted pair cable. And this has an extra metal foil covering surrounding the 4 pair, which is then again covered by an outside PVC covering. Extra shielding means extra money, so STP, or shielded twisted pair cable, can cost twice what UTP, unshielded twisted pair, does. But sometimes it's the right cable for the job. Whatever the increased cost, it is absolutely nothing compared to the labor cost of repulling the cable at a later time, or the dozens of hours it might take to troubleshoot data loss in cable areas that are having interference. So those few cents per foot extra will sound like a bargain later on if you do run into a problem and end up trying to save a few pennies. Do it right, do it once. If in doubt, use STP cable near fluorescent lights. That's shielded twisted pair cable. A little bit more money, but it'll keep your interference out. There's a second type of twisted pair cable to learn about, and it turns out that the PVC covering on the Cat cable is inexpensive, but it's particularly nasty when it burns. First, it burns easily, since it's derived from just petroleum products. It is a plastic. And the point of greatest concern is that it releases a very, very toxic smoke when it burns. So there have been instances in fires where people were fine from the heat and the smoke until the toxic fumes from those cables came and killed them. So we're particularly concerned with that PVC wrapping and not using it in areas where smoke might get into a room during a fire. So that PVC outer wrapping is kind of a lousy partner in a room with a human when there is a fire. And because of this, they make a special type of Cat cable called plenum cable, P-L-E-N-U-M. Plenum actually refers to the space in a building between floors, or an area where air can travel. And this plenum cable has an easier to get along with outer coating that has a specific fire resistance to it. It's used in areas between floors and office building and near ventilation ducts where fumes from a fire might travel. A similar cable that has slightly less stringent fire restriction resistant coverings, is called riser cable, which is used in vertical rises in buildings. So since plenum cable is created to the highest standard between the two, it can always replace riser cable. But the reverse is not true. You can never use riser cable when you're supposed to be using plenum cable because it's not quite as fire resistant. Both plenum and riser cable also have a high strength cord in them to help support the weight and longer cable runs and the vertical runs that they might experience in buildings. The Ethernet standard specifies that any one Cat cable run have a maximum length of 100 meters total, and if you're thinking in feet in the US, that's about 328 feet. Since the total cable distance from a switch or router to the computer also includes patch cables from the wall to the equipment, generally we limit cable lengths for permanent wiring, which is the wiring inside walls and ceilings, to 90 meters, which is just short of 300 feet. This leaves approximately 30 feet of wiring in office and still staying within the 100 meter requirement. So we have about 15 feet on each side that we can put patch cables to connect equipment. We're still compliant in that case with the standard. Again, the standard is 100 meters, but in wall we try to target 90 meters. For runs over 100 meters, an electronic device known as a repeater needs to be used to boost the signal. All connection devices like hubs and switches and routers act as repeaters, so we're basically measuring our cable lengths from these devices. Another quick review at this point. Ready? General cable is called UTP, unshielded twisted pair cable, and it's sufficient for general use. Remember to match the speed of the cable for the speed of your equipment. It's actually good practice to use the fastest cable that's affordable, since equipment speeds, you know, are going to be constantly going up. But the one-time cost of labor of running cable is extraordinarily high, so today, if possible, use Cat6 cable, or at least Cat5e. Shielded cable is used where there might be a radio frequency or magnetic interference problems, such as near motors or fluorescent lighting. Plenum and riser cables are used in special cases where the fire codes specify. Remember also that the maximum length of an Ethernet Cat cable run should be 90 meters, just under 300 feet, to allow flexible and patch cables to be used on either end, used to connect equipment and computers. So finally, let's talk about the wiring standards and the common connectors. The connector is known as an 8P, 8C connector. 8 position, 8 contact, because there's 8 wires. But most people call it by its telephone name, which is an RJ45. So those RJ45 plugs and jacks look kind of like fat phone plugs. These connectors have a long history in telephone usage, and they're defined by a set of standards known as the TIA-EIA, and that stands for Telecommunications Industry Alliance and the Electronic Industries Alliance, and these were defined in 1991. They defined a set of standards for telephones known as T568A, and later a second wiring standards for computers known as T568B. Each specifies a wiring order, but between the two pair are reversed in the standards. So it's important to use the B standard for network wiring. You can remember this because the A standard, which is for telephones, obviously came first, and the B standard for computers came second. So remember, we're always looking to use the 568B wiring standard when we're doing computer network wiring. Remember, there's 4 pair of wires, and each pair has a solid and striped wires. You'll also remember that we call the striped wire white-green or white-brown, and not the opposite, which would be brown-white. So in Ethernet networks up to 100 megabits per second, we only are usually using 2 pair of the wires, even though there's a total of 4 pair. The ones that we use are orange and green. And those are the tightest wound, so they provide the greatest resistance to interference. Here's the order of wires for the connector. First we start with the orange pair, and we do white-orange and then orange. And then we're going to kind of interweave the green and blue pair. So we next do white-green, and then solid blue, white-blue, and then solid green, and we end up with the brown pair together, which is white, brown, and brown. Let me go over that one more time. White, orange, orange, white, green, blue, white, blue, green, white, brown, and brown. So you'll notice a few things that can help you remember this order and when you're going to want to do that. First, the wires alternate between a striped wire and a solid. Second, the 2 pair on either end are with their mates. So we have white, orange, and white, brown, and brown. Third, the middle pair start with the white, green that we will be using, but then it jumps to the solid blue. The next pair must be striped because of our rule, so the remaining remaining striped wire is the white-blue wire. And the only other wire that's left is the solid green at that point. So since data is traveling on the orange and green pair, you can see that we're using pins 1 and 2, which is the orange pair, and 3 and 6, which is the green pair, to carry data. That's why the wiring is so important. If the data doesn't come through on pins 1, 2, 3, and 6, the cable won't work. Permanent wiring, which is done in the walls, uses Cat5 or Cat6 cable that is solid. Each wire is solid. It's 24-gauge wire. And these solid wires are relatively easy to work with, although they should not be bent at right angles or bent repeatedly so that they don't break, the wires don't break within the cable. So first, let's take a look at making a plug, an RJ45 plug, a task that's often required at a network panel or to mount equipment in junction boxes. Using a special wire cutter that pierces only the PVC jacket, we cut about 1 inch of insulation off the end of the wire, and we save that piece of PVC for separating the wires in just a moment. We'll separate the wires into the 4 pair, and then, as I said, use that empty PVC jacket to separate the pair. So now we have 8 wires all sort of fanned out. With all 8 wires separated, we organize them just as we stated above. White, orange, orange. White, green, blue. White, blue, green. White, brown, brown. And these can be lightly pulled or fanned between your thumb and finger to get them in line and cooperating. Once they're in the correct order and of even length of about 5/8 of an inch, they can be easily inserted into an RJ45 plug that has 8 little channels that these wires fit into. These plugs that we're going to use a compression tool on have 8 small little knife edges that initially are not pushed into the wire, so we're able to push the wire directly into a channel. These 8 knife edges are going to be pushed into their respective wires by a compression tool. So we put the wires in tight, and while we're holding them, we trigger the tool and we compress the plug pins, and you're done. You have 8 connections made. A similar process occurs at the jacks, either in a wiring closet or on a patch panel for each jack, or perhaps in the back of the wall office jacks so that we have convenient access to our desktop computers. Each company makes a slightly different jack, but remember that we're following the 568B standard. It will show you where each of the 8 wires will go by color. You just need to take a moment to decipher the color code on that particular jack, and you place the wires, all 8 wires, usually 4 on one side and 4 on the other, where they can be securely engaged, and use a spring-loaded, what's called 110 punch tool. Using compression, using a spring, pushes each wire in. This sort of fires each wire into a V-shaped connector, and we make a secure electrical connection that way. Unfortunately, it's impossible to show you every type of connector color diagram, so we're just going to take a few moments to give you a short visual survey. Following are a few different types of connectors. These are the backs of patch panels, and these are connectors that are used in RJ45 jacks. Now, once these are secure, you'll need to use known good tested cables at each end and connect a cable tester that checks the continuity of each wire in the cable. Once that's done, you can congratulate yourself for a job well done. And that's always a great feeling after you've used your punch tool and you've perhaps created some jacks, and you test the whole thing and all 8 wires light up and are continuous. So that's a satisfying moment of a job well done. If you're just starting out, I suggest that you start with Cat5 cable or Cat5e cable. Cat6 cable, which has that plastic coffee stirrer thing in it, is a bit trickier to work with, and it turns out that the wire is a slightly thicker gauge, so you need to match your Cat6 cable to Cat6 jacks and plugs that are a proper fit. So I want you to be aware that the plugs and jacks and connectors for Cat6 and Cat5 cable are different, especially the RJ45 plugs. Since the wire is a slightly higher gauge, the channels in that plug need to be a different size. So a little bit of review. We spoke of different types of Cat cable for different speeds and the standard wiring order for network cable. The slower speeds of 10 and 100 are less fussy, but higher speeds like gigabit have a means of using all 4 pair of wires and not just the orange and green. So always take the time to get it right and be sure that every single connection is continuous and consistent, and always test every single connection and cable run that you do. Inside the walls and ceilings, remember that we use solid Cat wire, but for patch cables outside of the walls, maybe connecting a computer to the jack on the wall, we use more flexible stranded wire patch cable. And you're going to be buying this, not making it. It'd be nearly impossible to punch or to make your cables with stranded wire. This cable has the same ratings of speed, but because of the stranded wire and because it's not solid, it's very pliable and flexible. Remember not to try to save a few bucks and make your own external cables from solid wire. It'll nick and crimp and look ugly and ultimately make you look bad for using it. Just one last item. You know that many computer devices like Wi-Fi access points and routers and small switches use those power bricks to supply power to them from the AC wall outlet? So if you have a lot of computer devices, you probably have a whole lineup of those power bricks that are taking up every outlet that you have. If you had to mount one of these small devices in an out-of-the-way area, and I've had to do this several times with Wi-Fi access points in like shopping malls and things like that where it's up 70 feet in the air, you would not only have to run the Ethernet Cat cable, but you'd also have to possibly wire an AC outlet close by so that you could plug that little power brick in, and that could be quite expensive. And it also increases the complexity of the job. So since most of these devices use low voltage, 5 or 12 volts, a means of running the power through the Cat cable has been devised. and appropriately it's called PoE, Power over Ethernet. In these situations, a powered switch or router is used that supports PoE, and the remote device talks to the powered device to specify the voltage it wants. So the power is sent through the two pair of wires that we're not using. Remember that our data in 100 megabit per second applications is going in the orange and green pair, so we have the blue and brown pair available that we can send voltage through. I'm going to add a word of caution, though. It's quite appealing sometimes to use PoE, and this idea is frequently used in commercial and business applications, but you really need to use high-quality equipment, because now you're sending actual power out on those Ethernet wires, not just the data on the orange and green wires. So if you use inexpensive or consumer quality switches rather than name brand business class equipment like Cisco, something might overload. They may not provide exactly the correct voltage that you're looking for. They might not talk, the switches that provide the power might not talk perfectly well to the devices and might send some kind of overload. They might short out, send overvoltage, or they just plain might not work or communicate properly. In this area, one wrong move and you can toast thousands of dollars of equipment. So again, advice to use good stuff. Test first, double check the device specifications at both ends, and wiring correctly is of course critical. You don't want to send voltage to the data line on a computer or switch or server or router. Ouch, that would hurt, blowing out those network cards. Okay, you're duly warned. Here's another quick review. Just about done here. We spoke of the 802.3 standard for Ethernet. We use Cat3, Cat5, and Cat6 cable for Ethernet speeds of 10, 100, and 1000 megabits per second, and that 1000 is also known as gigabit. The wires are twisted, tighter and tighter, and in an irregular way in a Cat5 cable to be resistant to interference, and in Cat5 we actually add a plastic separator running through the inside of the cable. Most cable that we use is UTP, unshielded twisted pair, with just a PVC jacket around it, but there is special cable known as plenum cable or riser cable that has a fire-rated covering for use in the plenum area above ceilings or in riser columns. STP, shielded twisted pair cable, is used in areas where there's magnetic, electrical, or radio interference. It has a foil shield surrounding the four pair inside the wire. We went over the correct wiring order for a standard known as T568B. Remember, B is for computer networks. And that order is white, orange, orange, white, green, blue, white, blue, green, and white, brown, brown. And that's when you're looking at the plug with the pin away from you and the plug up in the air, sort of like it was your thumb. The orange and green pair are twisted the tightest, and they usually carry the data. We talked about how to punch this solid wire into jacks and plugs, but always to purchase stranded patch cables for use outside of the permanent wiring. Remember that stranded cable is something that you're going to buy, not make. Finally, we talked about the idea of PoE, Power over Ethernet, which can supply power to a remote device using the Ethernet cable. That's it. Great work again. I've really enjoyed speaking with you. Again, I'm Arnie, the old computer guy from On Track Computer in East Hampton, Connecticut. I hope you've learned some of the details of using Cat cable for Ethernet and when to use specific cables. Good luck to you.